Okay, in this lesson, we're going to go over the properties of equality. These are the things you can do to an equation that will make the equation simpler, with the important fact of keeping the solution to the original equation the same. So in my first equation here, I have x squared plus 1 equals 7 minus x. And I'm telling you that the solutions to these equation, or this equation, is -3 and 2. So the first question just wants you to verify that those are actually the solutions. So let's check. Let's check -3. So wherever I see an x, I'm going to replace it with -3. So on the left-hand side, -3 squared is -3 times -3, which is 9, plus 1, which equals 10. And on the right-hand side, I also am going to get 7 plus 3, which is also 10. So -3 is a solution to that equation. Likewise, we can also check 2, x equals 2. This one also works because 2 squared plus 1 equals 7 minus 2. Right? They both give me the answer of 5. Okay. All right, so now we're going to take our original equation and we're going to start doing things to it. The first thing is it's saying let's add 4 to both sides. This is going to give me a new equation, x squared plus 5. And on the other side, it's going to be, well, 7 plus 4 is 11, 11 minus x. So here was my original, and here's my new equation. And what's interesting about this is that my new equation has the same exact solutions as the original. And you can check it, just like we did above. If I plug in -3 and add 5, that's going to give me 14. And if I do 11 minus -3, that is also going to give me 14. So by adding 4 to my equation, I get a new equation, and the answer is the same. So -3 is still the answer. Likewise, 2 would still be an answer, and we can check 2 on this side here. 2 squared plus 1 equals, this should be 2 squared plus 5, equals 11 minus 2. And 2 squared is 2 times 2 is 4, plus 5 is 9. 9 equals 9. Okay, so what are some other things we can do besides adding an amount like 4? Well, could we add an amount, an unknown amount, like add x to both sides? So let's check. Add x, add x. What new equation would I get? So this is like your original now. And my new equation, well, that would be x squared plus 5 plus x. There's nothing to combine on that side. But the right-hand side would just be, well, the -x plus x would make 0, and I would have just 11. So here's a new equation. Are my answers kept the same, though? That's the important thing. We only want to do things to an equation that will keep the answer the same. So let's check -3. negative 3 squared plus 5 plus negative 3. Will that be the same value as 11? Well, negative 3 squared is 9, plus 5 is 14, plus negative 3, that is 11. Yes, 11 does equal 11. And 2 would also happen to be the exact same answer. Or 2 would also be a solution to the new equation. Okay. So we can add a constant amount to both sides. We can add a variable term to both sides. And maybe it's obvious that we can subtract 5. Maybe it's not obvious. But I'm going to leave this one. I'm going to leave this one for you to do. So have support and work that subtracting 5 to both sides would keep the original answers of negative 3 and 2 the same. All right, we're next going to check, how about multiplying? Now, what's different about multiplying an equation is every single term that makes up the equation has to be multiplied by that amount. So if I want to multiply this equation by 1/6, every term is going to get multiplied by 1/6. That's going to make the new equation 1/6 x squared plus 1/6 x equals 1. Will this equation have the same answers as negative 3 and 2? Let's check it for 2. 1/6 times 2 squared plus 1/6 times 2. Will that equal 1? Okay, order of operations says to do the exponents first. So 2 squared is 4. 4 times a 6 is 4/6. Plus 1/6 times 2 is 2/6. And does that equal 1? Yes. Yes, it does. So 2 is also preserved after I multiplied by 1/6. For F, they wanted you to go back to part D and try adding 3x squared onto both sides and checking that your solutions would be the same. I'm going to leave that one for you. So these are the properties of equality. And you'll notice that when we did the properties of equality, we are allowed to add or subtract by constants, but also variable terms. When we multiply or divide, right, we only allow you to do it by constant amounts, except 0. So the question is, why can't we multiply by variable terms? Okay, and that's what exercise 3 is going to show us. So here I have an equation, x minus 3 equals 5, and I want to verify that the answer to that equation is 8. So how can I check that 8 is actually the answer? Well, I can do 8 minus 3 and check, does that equal 5? And yeah, it sure does. 5 equals 5. Okay, but now I'm gonna take the equation and now I'm gonna multiply by x. Now remember, as we did above, every term has to get multiplied by x. And that's going to make this new equation x squared minus 3x equals 5x. So now the question is 8 still an answer? Well, Let's check. 8 squared is 64 minus 24. Will that equal 5 times 8, which is 40? And the answer is yes. 64 minus 24 is 40. So x equals 8 gets preserved, but something else happens along the way, is that we actually made a new solution. What new answer will we actually get? It's actually going to be 0. Let's check 0. 0 squared minus 3 times 0 equals 5 times 0. This would say that 0 minus 0 equals 0. And that's true. 0 does equal 0. So not only did we preserve the solution, but we actually created one as well. And 0 would not be true for the original equation that we were trying to solve. So that's the potential harm with multiplying by a variable term, or even dividing by a variable term, is that you might create or possibly lose solutions to the equation that you're actually trying to solve.